Azure ML Studio provides a total of 25 algorithms. Depending on where we are going to use this algorithm, we can choose an algorithm by following this green start. Is it a classification problem in which we select one of several categories? A problem of finding a structure? Or is it a problem of anomaly detection? Depending on that, you may choose another one. Because we are solving a regression problem predicting values, just follow this arrow here and choose the algorithm. If you follow this side, there are a total of 8 algorithms corresponding to regression. What is the difference between each of these 8? Let's see which problems can be solved well. Now let's look at the 4 algorithms first. The first is ordinal regression. When I hear the name of the ordinal regression, it feels very strange. However, ordinal at the front of this term originates from the word order. Order means normal order. So, when the problem we want to predict is what ranking, order, etc., a good algorithm to use is ordinal regression. So, for example, ordinal regression is used when you want to predict which of a number of brands users like, order them, and who will end in what order in a match or competition. This is the second Poisson regression. Passion regression doesn't seem to be English. Yes, it's from French. It's an algorithm that follows the Poisson distribution developed by a mathematician named Poisson. So, this value is an algorithm used to predict how many times a certain event will occur. So, for example, how many times will you get colds depending on the number of times you boarded the plane and the region? And how many emergency calls will be made to a doctor in a hospital? Poisson regression is used when you want to understand the number of occurrences of such an event and the number of visits. So, this ordinal regression and Poisson regression are there where you want to predict the order or number of times, so the value can never be negative. When preparing data, you should also check if there is a positive integer value. If there is a negative value or a decimal value, the model will not train normally, and it will predict the values strangely. And there is a third linear regression. You can think of this linear regression as the most common statistical approach. So it's good to use it when the amount of data we have is small. If it's a little complicated, it may not be suitable for linear regression. And the fourth is Bayesian linear regression. Bayesian was added in front of the linear regression. So you can think of using the Bayesian approach to the general regression technique. We generally think that any event or thing that happens will happen independently. But the Bayesian technique is to think that what happened earlier will affect this later. Therefore, it is good to use Bayesian linear regression when several features we have some correlation with each other. Next is neural network regression. This neural network regression is an algorithm using artificial neural networks. You can think of it as similar to the deep learning. So, if you use this algorithm to solve a more complex problem, you can see a little higher performance, but it takes a long time to learn. Then there are 3 remaining: decision forest regression, boosted decision tree regression, and fast forest quantile regression. These 3 have something in common: binary classification called decision tree. is based on the decision tree shape algorithm. So, these three show higher performance when solving a more complex model than the linear regression we saw earlier. Especially boosted decision tree regression is one of the most widely used algorithms recently. And fast forest quantile regression is slightly different from other regression algorithms. If other legion algorithms were created with a focus on finding the correct value, this quantile regression is good for predicting the percentage distribution. So, when we want to know what the overall distribution of values is rather than predicting the value of one unit, we can use this fast forest quantile regression. We looked at these 8 algorithms. The problem we are solving now is predicting Walmart's weekly sales. Among them, there are algorithms that can be used and algorithms that cannot be used in the problem we are solving. Have you found which one shouldn't you use? The ordinal regression to predict the order and the Poisson regression to predict the number R doesn't fit our problem. So, out of a total of 8 regression algorithms provided by Azure ML Studio, we will train the model by selecting some of the remaining 6 except ordinal regression and Poisson regression. Then, let's go back to Azure ML Studio and train the model. We move to Azure ML Studio. Then we are ready to train the model. Let's first connect the algorithm we use here. Algorithms are in this part of the module category called machine learning. Here, there are 4 types of evaluate, initialize model, score, and train, and we will use all things. The first thing you need to use is the initialize model. Initialize model means which algorithm to choose. If you open it here, there are for anomaly detection, classification, clustering, and regression. You can choose depending on which problem we are going to solve. We're solving a regression problem, so please choose a regression. Here are 8 algorithms. The name is not so strange. These are the algorithms we saw earlier. Here, you can try using anything except Bayesian regression and ordinal regression. First, let's use the simplest linear regression. Algorithm puts it a little on the left side. Then I will come up with a trained model that can actually be trained on this model. You can bring out this trained model and place it about here. This trained model has 2 circles at the top. There are 2 circles because one side has to get what algorithm to learn with, and the other circle has to get what data to learn with. I'll connect each one. Connect the algorithm and the front circle of the trained model like this. Then, connect the data of 80% of the front circle of the split data with the back circle of the trained model. Then, we are going to train 80% of this data with an algorithm called linear regression. But you connected it well, but a warning will appear in red. The reason is that this trained model received data and received an algorithm. And this algorithm is now a supervised learning algorithm. However, from the standpoint of this model, out of the 11 columns we have, which is the label value and which is the correct answer value, it has not yet been informed, so an error appears. So, with this selected, open the Launch Column selector in the Property window in the right. Here, when all the columns we have, you only need to select one label value. Which of these is the value we want to solve, the value we want to know, or the value we need to predict? That's weekly sales. Choose one and send it to the right. Click the check button at the bottom. Then the label column goes into weekly sales here. The red warning will disappear. In this state, when we train, a model is created immediately. When the model is created, we will immediately proceed with the evaluation. So, I'll connect the score model that can be evaluated. If you open the score in the module category, there is a score mode. Please come out with this score model. This score model also has two circles at the top. It means which model will be evaluated with what data. Connect like this. Data can be connected to this circle. After connecting like this, if we right-click and run selected, everything at the top will be done on the server at once. I'll click. When the training is done like this, green checks will appear on the added 3 models. If we click the circle at the bottom of this trained model and visualize it, we can see right here how the trained model has values. In this case, an algorithm called linear regressor is used, and feature weights are shown at the bottom. Here, feature refers to a column that affects the result value among the data we have. So, what number store is, and what type is it? Then, if you go down all the way, the right weights will be given depending on whether the day was a holiday, how much fuel price, and how much unemployment rate. So, how much each feature affects sales volume is calculated here. So, if this weight value is negative, it has an inverse effect on the sales amount. Conversely, if it is a positive value, it means that it has a good effect. If the day is a holiday, you can see that it has a positive effect. Then, as the fuel price increases, the weight value is negative. You can see that it has a more opposite effect. So, the higher the fuel price, the lower the sales. Then the unemployment is the same. You can see that the higher the unemployment rate, the worse the sales volume. In this way, when the model is trained by looking at the data, you can see how much each feature affects the sales volume of the result and how it has a relationship with the weight value here. So, the model was trained with these values, and it is to evaluate whether the model made like this works really well. It shows the model from which the score model was built and new data that we didn't show when we were training, and asks you to tell us how much sales the model predicts in this case. So, if you click on the circle at the bottom of the score model to visualize it, remember earlier? Obviously there were 11 columns, but now it has increased to 12. The reason is, when the temperature, fuel price, consumer price index, unemployment rate, etc. come in on this data store like this. Finally, since the scored labels column, which says what value the model predicts, was added, there were a total of 12. So, you can think of the scored label here as the predicted value by the model. So, the weekly sales in the front are the actual results we had originally. This scored label is what the model predicted when looking at this data. So, if you look at the difference between the two, you can see how well the model fits. If you compare it slightly, the original data has a value of about 11,000. But the model predicted is about 10,500. Isn't it pretty similar though? Then look at the second. It was originally 40,000, but the model predicted that it was about 60,000. After that, it is 1,700, but the model is short. I predicted it was minus 3,800. Well, if you compare the values in this way, sometimes it seems a little similar, and sometimes it seems that there is a lot of difference. However, it is difficult to compare at a glance how well this model fits just by looking at these two values. So, there is another module we use, which is the evaluate model. Score model literally checks what value the model gives under these conditions. When comparing the values one by one, it is difficult to judge how well this model is made. So we bring one more module, evaluate model, and connect the models like this. In this state, if you right-click the evaluate model and run selected, the above is simply how much the model predicts under these conditions. If you see this, in the evaluate model, the difference between the original value and the predicted model is calculated at once. And the indicator that can judge the model and the metric of the model. When the result is finished running, I'll click the circle to visualize it. Then here, called the matrix, we can see the performance of this model. If you look here, min absolute error, and root mean squared error, relative absolute error, relative squared error, and numerical values corresponding to coefficient of determination are shown. But you have to find out what these values mean. And then look at these values.